Hey folks, how's it going? Mr. Murray here, and I am coming to you this evening with a breakdown on this riddle that you were assigned. And this riddle is, according to the famous TV critic Bube Tube, I guess that's how you pronounce their name, why is television called a communications medium? All right, this riddle, copyright the wonderful resource book for teachers, Algebra with Pizzazz. When this was assigned, as a reminder, you are expected to show all work in order to receive credit. So no work, no credit, some work, some credit. Because, right, I honestly, you're resourceful people, you could probably look this up online and get the answer like that, like the answer to the riddle. That's not what matters to me. What matters to me is that you guys get practice with the fundamentals. So in this video, what I'm going to do is I'm going to, one, remind you guys the process over how you solve absolute value equations and inequalities. And then what I'm going to do is I'm going to actually go through every single one of these problems, getting the answers, and I'll do the riddle with you. Very likely I'll have timestamps in the description, which hopefully will enable the chapters feature if you're in the main YouTube site. And so you can browse at your own pace, go through the problems you want to go through, and get an understanding of where you're doing well and where you need to improve. All right. Okay, so let's jump into it. All right, so remember the steps to success when you're solving an absolute value equation or inequality. Number one, bars alone. The very first thing you need to do is you have to get the bars alone. You cannot make any assumptions until those bars are alone. And I'm betting, right, because there's 4 questions per column, but 6 answers per column. And I'm betting that some of that is getting at those misconceptions when you do not get the bars alone. So get the bars alone, please. And that's why I made that corny joke in class, because the number one thing that folks don't do is they don't get the bars alone. It's not because I want to make you like cringe. It's not because I want to make you look at the clock and know when class is going to end. I don't want you to make that mistake that so many people often make when they do absolute value stuff. All right, 2, determine the solution type. So that's going to matter if it's an equation or an inequality. So you got the bars alone. You're going to take a look at the other side of that equation. And if the stuff with the bars is equal to a positive number, that's going to indicate 2 solutions. If the stuff with the bars is equal to 0, that's going to indicate 1 solution. And if the stuff with the bars is equal to a negative, no solutions, 0 solutions. And again, that is because if you have the bars equal to a positive number, there are 2 different numbers that will have an absolute value that is a positive number. So for example, if the absolute value is equal to 10, 10 and negative 10 have an absolute value of 10. So that's indicating that there will be 2 solutions. Only one number has an absolute value of 0, and that is 0. And then finally, because absolute value, remember, is basically a kind of distance, and distance has to be positive or 0. It can't be negative. So therefore, if the bars, stuff in the bars is equal to a negative number, you're going to have no solutions. As far as I know, this didn't happen in this particular riddle. It did happen in the other riddle we did in class, but it didn't happen in this particular riddle as far as I can tell, but we'll see when we jump into the problems. All right, that's if we have an equation. If we have an inequality, it's going to be slightly different. So if the absolute value, the stuff in the bars, is more than a positive number, you're going to have an or inequality. So it really matters what way the inequality is facing. And you're going to see that there were some or as well as some and inequalities in the answers to this riddle. All right. If the absolute value, I maybe get my hand in the right area. If the inequality is pointing towards the number and it's a positive number, that's going to be an and inequality. And I encourage you to go back and look at 4 and 9, where we really kind of tried to conceptually break down why that is. If the absolute value stuff is less than a negative, you have no solutions. And remember, that's because absolute value needs to be positive or 0. So it can't be negative. So it can't be less than a negative number. No way that can happen, no solutions. And finally, for a similar reason, if the absolute value is more than a negative, you're going to have all real numbers or negative infinity to infinity being your solution. Keep in mind, if I had put or equal to for any of these inequalities, that would have no impact on the analysis. Okay, so greater than or equal to a positive would still be an or inequality, and less than or equal to a negative would still be no solutions, and so on. When you have 0 on the other side, that's kind of like a special case. We didn't get into that too much, and we'll see what happens if that comes up. Usually when it's 0, it will be like everything but one number, because 0, again, is a kind of tricky number. So we're probably not going to see that, but good to know it's a special case. So now once you've identified if it's an equation, the number of solutions, if it's an inequality, the type of inequality, assuming that there is something you need to solve, you're then going to go ahead and solve that out. So if it's 2 solutions, you're going to have 2 equations you need to solve. Remember, by the time you get to step 3, okay, the bars are going to be gone at this point. Okay, the absolute value bars are going to be gone, and going from 2 into step 3, that process of splitting it into what you need to solve is part of taking off those absolute value bars. All right, so what I'm going to do now, I'm going to jump into our first set of problems. And as you can see here, these are problems 1, 2, 3, and 4. That first column, I encourage you to reference your sheet so you can see that these are the same exact problems there. All right, let's go ahead and solve. So here we have the bars alone. So I'm going to ask myself, what number has an absolute value of 7? So one number that has an absolute value of 7 is positive 7. So if x plus 2 is equal to positive 7, then this will work because I'll have the absolute value of 7 equals 7. And then if x plus 2 equals negative 7, if I can make the stuff inside the bars equal negative 7, when I take its absolute value, I'll also get 7. So that has to indicate another solution. What I really like about this is that actually getting x alone is the same in both steps. You're going to minus 2 and minus 2. I love that. So 7 minus 2, that's going to give me a solution of x being equal to 5. And here you're going to have x being equal to negative 9. And remember, how you're going to know you're right, ultimately, you take the number, you plug it back in, and both sides of the equation are equal. Okay, do be aware that the order here might be slightly different than the order in the worksheet, but the order of the 2 numbers doesn't matter. So here we have 5 and negative 9, and in the worksheet that is associated with EI. Okay, great. So let's go to the second one. And of course, anytime, feel free to pause, rewind, go through any problem if you think that I missed something or if there's something you need additional clarification on. Okay, here again, the bars are alone. So I'm going to ask myself, what numbers have an absolute value of 16? So one way to make this true is if 3x minus 6 equals 16. And the other way is if 3x minus 16 equals negative 16. Because negative 16 and positive 16 have an absolute value of 16. So being able to, again, associate having the bars alone, having the right-hand side being equal to a positive number, associating that with 2 solutions is really important. All right, and I did notice I made a little slip up there. So it's 3x minus 6. Okay, so I'm going to solve by adding 6 on both sides. 3x equals 22. And then I'm going to divide by 3. And I get x equals 22 over 3. And 22 over 3 is not an exact number. So let's take a look at this. Oh, and you know the reason is because I made one little goof up, and it should actually be 15. That makes a lot of sense. So let's go ahead and just fix this. All right, let's try one more time. So then instead of having 22, we'll have 21, and then we'll have 21 over 3, and that is 7. All right, and we're going to do the same thing, but with negative 15, because that's the other number that has an absolute value of 15. So I get 3x equals negative 9, divide by 3, divide by 3, and I get x is equal to negative 3. And now you should see 7 and negative 3. That is going to be, let me just circle my answers, and that is going to be En. Okay, now we have 9 plus 4x equals absolute value equals 1. Bars are alone, so I'm going to ask myself, what numbers have an absolute value of 1? One of them is 1, and the other is negative 1. Here's a little bit trickier. I'm just going to start by subtracting the 9. One thing we do have to remember is you just want to get rid of the addition or subtraction before the multiplication and division. So you basically do PEMDAS backwards. First, you get rid of the addition subtraction, and then you get rid of the multiplication division. Some people say like SADMEP. All right, so 1 minus 9 is negative 8. Negative 1 minus 9 is negative 10. I divide by 4, giving me negative 2. I divide by 4, giving me negative 10 fourths. Now you do need to do a mixed number. So that's negative 2 and a half, 2 fourths. And we have negative 2 and negative 2 and a half. And there is a match, and that match is to HE, as in he, which is what you'll be saying when you solve this amazingly funny riddle. All right, last one again, bars are alone. So you notice like the theme here is that the bars are alone. 20 minus 7x equals 8. That's the common thread. So you have 20 minus 7x being equal to 8, and 20 minus 7x being equal to negative 8. So I'm going to minus 20, minus 20, minus 20. So minus 20 on both sides of each equation. I get 7x. 8 minus 20 is negative 12. Negative 8 minus 20 is negative 28. Then I divide by 7. And I get negative 12 over negative 7. So first of all, that's a positive number because a negative divided by a negative is a positive. And 7 goes into 12 once with the remainder of 5. So 1 and 5/7. Okay, and then you do the same thing here, negative 7, negative 7. And that gets me positive 4. Okay, and then I'll go back to my front sheet, and I'll find that this is next to not he, but we. Okay. So those are my 4 answers. I have EI, EN, HE, WE. So I'm going to come back here. EI is going to go in box 1. EN is going to go above box 2. HE is going to go above box 3. And WE is going to go above box 4. All right. There we go. That is the first one. All right. So EI, HE, EN, WE. So you can see there's 2 left over. Those are probably going to happen if you make little errors. I'm sure there's little errors that are baked into them. All right, part 2. These are going to be inequalities. Again, the common strand here is that the bars are already alone. You are now going to have to analyze the kind of inequality. So you have absolute value of n greater than 3 absolute value of n less than 4, absolute value of n minus 6 greater than or equal to 7, and absolute value of n plus 3 less than or equal to 12. So when we did the activity on 4.9, I kind of walked through the different types of inequalities, and I really highly encourage you to take a look at that video. So here I'm going to ask myself, what numbers have an absolute value that is that's more than 3? So let's think about that. 4, the absolute value of 4 is 4. That's more than 3. The absolute value of 5 is 5. The absolute value of 6 is 6. 7 is 7, 8, 9, 10, 11, 12, and so on. All of those numbers are going to have an absolute value of more than 3. 3.1 will have an absolute value of more than 3. 2 has absolute value of 2. That's actually less than 3. So on one hand, we have all of the numbers that are more than 3. But is that all? It's not, because what about negative 4? Negative 4's absolute value is positive 4. That is more than 3. Negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, and so on. All of those values have an absolute value that is more than 3. So the numbers that are more than 3 and the numbers that are less than negative 3. And now those are two distinct pieces. You can imagine those are not connected to each other. So what we're going to do, we're going to put an or in between. And what we get is n is more than 3 or n is less than negative 3. And that is us. Okay? So you really just have to think through it logically. Think about what does absolute value mean? Think about what kind of numbers could work here. And it doesn't matter whether it's just n in the bars or maybe like as you see n minus 6. Ignore that part. Put your finger over it if you need to. All right, and just think what kind of numbers could work for this inequality. All right, n is less than 4. So here is not, see how the bars are alone as with the other one, but the inequality is facing in a different direction. So what kind of numbers have an absolute value that is less than 4? 0, the absolute value of 0 is 0. That's less than 4. Absolute value of 1 is 1. That's less than 4. Absolute value of 2 is 2. Of 3 is 3. Of 4, well, the absolute value of 4 is 4. That's not less than 4. It's equal to 4, so that wouldn't count. Negative 1, that absolute value is less than 4. Negative 2, negative 3, and negative 4 also not working as with 4 because it's your cutoff. So what we need are the numbers that are less than 4 and greater than negative 4. All the numbers between negative 4 and 4. So when you're thinking about things that are between, remember between went with and. Remember we shaded between the points. Whereas outside went with or, right? Outside and or, right? Remember they said we both start with O's. So negative 4 to 4, and that one goes with it. Okay. Next one's a little bit more challenging, but that's only because we have a little bit of a more complicated expression. So we're just going to solve that out. All right. So again, what numbers have an absolute value that is greater than or equal to 7? So 7's absolute value is more than 7 or equal to 7 because it is 7. So the n minus 6 could be 7. It could be 8. It could be 9. It could be 10. It could be 11, 12, 100, 1,000, 1787, 2021. If n minus 6 is any of those numbers, we're good to go. So n minus 6, in other words, could be greater than or equal to 7. But wait a minute. What if n minus 6 was negative 7? That absolute value is equal to 7. So it would be greater than or equal to. If n minus 6 was negative 8, negative 9, negative 10, negative 11, all those absolute values are more than or equal to 7. So in other words, n minus 6 could also be less than or equal to negative 7. Okay, and this is an example again of an or. Okay, now think about the pattern though. What do you notice about the numbers to the right of the inequality? One of them is the same as that number that's on the right of the original one. Well, in this case, the bars are alone. So one of them is the same as it, and one of them is the opposite. So start to think about those patterns. I like to teach it in terms of conceptually, what does it mean? But there are people who teach you in terms of that, like looking for the number and the opposite. Okay, so now we need to solve these one at a time. So I'm going to plus 6, n is more than or equal to 13. The or will stay or. I'm going to add 6. And again, as with equations, how you get n alone or whatever letter it is alone is the same for both pieces. Okay, so either n is more than or equal to 13 or n is less than or equal to -1. And that is going to go with BE. And actually, it turns out is in exactly that order. Okay, last one we have here, n plus 3 absolute value less than or equal to 10. Okay, so the bars are alone, so we're good to break it down. So what numbers have an absolute value that's less than or equal to 10? 10 does, 9 does, 8, 7, 6, 5, 4, 3, 2, 1, 0. All of those numbers have absolute value that's less than or equal to 10. But -1 does, -2 does, all the way up to -10. So as long as x minus 3 or n plus 3, that is, as long as n plus 3 is more than or equal to 10, more than or equal to -10, and less than or equal to +10, you're going to be good to go. Okay, and again, notice the overlap. You make an inequality, you put n plus 3, whatever in the bars in the middle, and then you put the number to the right and its opposite on either side. So you end up with -13. Remember, you're going to subtract based on where n's at, right? You want to get n alone. So you're going to -3, and you're going to remember to do it to all three sides. So -13 is less than or equal to n, which is less than or equal to 7. And that one goes with AR. R. All right, so as always, feel free to go back, rewind, play it back at your own speed if you need a recap. But what I'm going to do is I'm going to go ahead and I'm going to plug this in. So we have us, it, B, and R. Okay, so we have us, it, B, BE, BE, and AR. US, IT, BE, AR. Okay, just as you see here. All right, moving on, 9 through 12. So again, bars are alone. The same concept that we just talked about applies. It's just going to be a little bit more complicated to solve the absolute value due to the fact that we have a little bit more work to do inside of the bars, but not a big deal. So again, the bars are alone. We're good to go. So what kind of numbers have an absolute value that is more than 12? 12 doesn't, because that's absolute value is equal to 12. But 13, the absolute value of 13 is 13. That's more than 12. The absolute value of 14 is 14. That's more than 12. 15 has an absolute value of 15. That's more than 12. 16's absolute value is more than 12. So 17s, 18s, 19s, 20, 25, 87, 1,024, 532. So in other words, if 2D minus 8, and sorry for that little mark there, let me just, I'm a little bit picky there. So if 2D minus 8 is more than 12, you're good to go. Now, are we done? Well, let's think about it. What if 2D minus 8 was -12? Now that wouldn't work because the absolute value of -12 is 12. That's equal to 12. It's not more than it. But what if 2D minus 8 was 13, -13? The absolute value of -13 is 13. That is more than 12. If 2D minus 8 was, say, -20, the absolute value of -20 is 20. That's also more than 12. negative 30, negative 40, negative 50, negative 60, negative 1,352. All of those numbers have an absolute value that is more than 12. So we also need 2d minus 8. It could also be less than or equal to, that is, sorry, not equal, just less than negative 12. So this is what we have. Okay, that's going to be a situation where you're going to have an or. Now, how do I know it's an or? Just by, if you think through it, how I know it's an or. Think about the numbers that I talked about. 12, 13, 14, 15, 16. They all go up in one direction. Negative 12, negative 13, negative 14, negative 15. They go down in the other direction. So the numbers, if you think about them on a number line, right? Those numbers, those intervals of numbers where this inequality is true, okay, if you were to shade them, they're going to point away. And when they point away, that's a sign that you have an or inequality. All right, so now I'm going to get the letter alone, the letter in question alone. I'm going to add 8 on both sides, and 12 plus 8 is 20. I divide by 2, and I get the letter D is more than 10. Same thing on the other side. I'm going to do 2D is less than negative 4, divided by 2, divided by 2. So we get or the letter D less than negative 2. So either the letter D is greater than 10 or the letter D is less than negative 2. That is our final answer for this inequality. And that goes with the letters T, S. All right. Moving down to the next, by similar logic, we're thinking about what kind of numbers have an absolute value of less than 20. And those would be the numbers that are between negative 20 and positive 20, negative 19, negative 18, negative 17, and so on, all the way down to 0, and then 1, 2, 3, 4, 5, all the way up to positive 20, not including positive 20 and negative 20, have an absolute value that is less than 20. So we do that. Remember how we solve an and, we minus 5, minus 5, minus 5. So I get negative 25 less than 5D less than 15. Now I divide by 5, divide by 5, divide by 5, and I get negative 5 less than our letter D less than 3. Okay, lock in that final answer. Another thing you're going to notice that if you plug in negative 5 to the original inequality, you get negative 20. And that is as low as you can go and have an absolute value that's just on the brink. And if you plug in positive 3, you get positive 20. So that's another interesting thing, plugging in and you actually get the number on the other side. And this inequality is going to go with NE, as in New England. All right, here you're also going to get inequality, negative 6 less than 3D plus 18. Less than 6. Okay, thinking back to the logic that I thought through earlier, thinking about what numbers have an absolute value less than or equal to 6. That's going to be all the numbers between negative 6 and 6. And because it's between those two numbers, that's a sign of an and. So I'm going to go ahead and I'm going to minus 18 from all three sides. And I get negative 24 less than 3D. And don't forget our equals, less than or equal to 3D. Less than negative 12. And I'll divide by 3, divide by 3, divide by 3. And I'll get negative 8, less than or equal to the letter D, less than or equal to negative 4. And that is going to be like the letters OR, as in what this inequality is not. It's not an or inequality, it's an and inequality. That being said, this last inequality is an and inequality, is an or inequality, because again, bars are alone, inequality is eating the bars. So we ask, what numbers have absolute value that is more than 7? 8, 9, 10, 11, 12, 100, 1,000, 1,000,000, all those numbers more than 7. But also negative 8, negative 9, negative 10, negative 11, negative 12, negative 100, negative 1,000,000. All the numbers that are less than -7, okay? So now we're going to get this alone. And again, notice how when you solve, the process of getting our letter alone is actually going to be the same on both parts. Okay, and we're going to see what that looks like. Now, again, just as a heads up, remember what's going to happen here. So be really, really careful. You're going to need to divide by -2. And I would bet money that where they're going to get you here is you got to remember, when you divide by a negative, you flip the direction of the inequality because you divided by a negative, and then everything proceeds as usual. So D is less than -1. So if you're getting more than -1, perhaps you forgot to flip the inequality. Here I'm going to -5, -5. You can see it starts the same way. It's basically the exact same procedure because the stuff that's in the bars is the same, and that really determines where you go from here. Okay, so just like those crossed out, these are going to cross out, right? Because we had to cross out. These cancel. These cancel. Again, we flip the inequality. -12 divided by -2 is 6. Okay, this is an OR inequality. So we bring our OR back down in the end. We get D less than -1 or D more than 6. And that is CA, like California. Okay, so we have TSNEORCA. TSNEORCA. Okay, so we have TSNEORCA because it's, I'm dying to know what the answer to this one is. So we better do these last ones. So the last one's a combination of absolute value equations and inequalities. What's different? The bars are not alone. Okay, so remember, you have to get the bars alone. Okay, we've been taking for granted so far they aren't. Okay, so what we want to be really analyzing is y plus 1 absolute value is equal to 10. This is the point you remove the bars. So you don't go, what numbers have an absolute value of 60? I'm looking at what numbers have an absolute value of 10. And so I'm looking for y plus 1 to be equal to 10, or for y plus 1 to be equal to -10. Okay, and by minusing 1 on both sides, I get y is equal to 9. By minusing 1 on both sides here, I get y is equal to -11. So 9 and -11. And I can see this one goes with DO, as in do you love doing this as much as I do? Huh. All right, the next one, we got to get our bars alone. So similarly, we're going to start. And remember, you almost think about as if the bars were a variable. Okay, imagine if you had to solve 3x plus 15 equals 21. Think about how you'd get x alone in that scenario. First, you'd have to minus the 15 on both sides. Then you'd have to divide by 3 on both sides. Same exact idea. So I'll do this real quick to show you what I mean. So first you have to minus 15, get 3y equals 6. Divide by 3, you divide by 3, y is equal to 2. And actually, we use the letter x, so I should be very careful here to use letter x. So you get x equal to 2. In any case, the idea is it's the exact same principle, okay? Except now you're getting the bars alone. But the way you do that is the same as the way you saw for any old variable. That's what I'm trying to get at. So what numbers have an absolute value that's equal to 2? Well, one of them is 2. The absolute value of 2 is 2. And the other one is -2. See, this is me creatively trying to get a minus sign. So we'll add 8 to get y alone. So 2 plus 8 is 10. We will add 8 as well in the other one. -2 plus 8 is 6. And we have 6 and 10, which is another NE, New England, best football team in the NFL, the New England Patriots. Sorry if that's a little bit controversial there. All right, the third one, let's go ahead and get the bars alone. It's an inequality, but I'm going to change up my color just to get fun with it. So I'm going to divide by 9 to get these bars alone. And I have 2y minus 4 is greater than or equal to 4. All right, so what numbers have an absolute value that is more than or equal to 4? So first of all the numbers that are greater than or equal to 4 will have an absolute value that is greater than or equal to 4. But also all the numbers whose absolute value is less than or equal to negative 4 will also have an absolute value that is greater than or equal to 4. All right, so I have this OR inequality, so I'll go ahead and add 4 on both sides. Plus 4 plus 4, I'll just do one at a time. So 2y is greater than or equal to 8. Divide by 2, divide by 2. So y is greater than or equal to 4. Okay, on the other side, I'll add 4, add 4. 2y is less than or equal to 0. That'll be nice because when you divide 0 by 2, you also get 0 because 0 divided by anything is 0. So you get this nice little inequality here, y greater than or equal to 4 or y less than or equal to 0. It'll be LL, two things that you're not taking because you're going to be an expert with these. And lastly, this last one, we're going to get the bars alone, and that will just involve going to bars alone by adding ourselves a good old 5. So we're at 35. Bars are alone. Now, what numbers have absolute value less than 35? That would be all the numbers that are greater than negative 35 and less than positive 35. Okay, and to get y alone, we're going to minus 14, and minus 14. Okay, so we get negative 49 less than 7y less than 21. Now we're going to divide by 7, divide by 7, divide by 7. And I get negative 7 is less than y, which is less than 3. Okay, and this goes with RR, like the railroad. Okay, so again, always encourage you to rewind, pause, go back, replay at a lower speed or whatever speed is best for you. But we've got DO-NELLRR. So that'll wrap up this one. Let's see what we get. So we have DO, then the next one was NE, 14, NE. DO was, I believe, 13. So let's just make sure, put that in the right place or this riddle will not make sense. DO, and that's DO, and E, LL, RR. And let's type out what that final riddle answer ends up as. Because it's neither rare nor well done. Oh, because it's neither rare nor well done. It's medium. Okay. That is definitely a joke that I will not fault you if you do not laugh at, but that appears to be our riddle answer because it's neither rare nor well done. And if you got to explain it, it's not funny. But as a basic explanation, if you guys have ever had your, how do you want your burger cooked? If you ever go out or you have a burger and you say medium, right? You got rare, which is not much cooked at all, medium, which is in the middle, or well done, which is definitely cooked through. So that is it. That is why television is a communications medium. This guy was quite the jokester here. So in any case, guys, I hope you enjoyed this video going through this worksheet step by step. I'm trying to get this video to you so I can make sure you can make sure you're ready for any kind of upcoming assessments. Again, credit to Algebra with Pizzazz for the riddle itself. I did not make this. I don't take credit for this. copyright goes to them. But I did want to make sure I gave you all a step-by-step breakdown in terms of how this one works. Thank you so much, guys, for watching. I appreciate the time. Don't forget to like and subscribe so you can be aware when my new videos come out. Stay positive. Don't forget to love math. And remember that you can do it. All right, folks. Thanks so much again. Have a wonderful day, and I'll see you next time.